is what a standard hard start kit looks like. This is the run capacitor on the right hand side of the cabinet, the start capacitor on the left side, and the start relay at the top. So don't forget the 2x4 tool. Sometimes a good whack with a 2x4 can get a stuck compressor running. When I worked in Phoenix, Arizona, the air conditioner on my cousin's house stopped working. He called me out to see if we could get it running again. The first thing I did when I got there was to whack the compressor a couple of times with a 2x4. The compressor took off and ran and sounded just fine. That Tecumseh compressor ran for another 8 years, at which time my cousin replaced the unit with a new one. So don't forget the 2x4 tool. Don't confuse a start relay and start capacitor with these types of start kits. Some of these kits are fine and work well, but they're not sized and designed for particular compressor specifications. There are usually 2-wire connections that connect across the run capacitor's terminals. The PTC type soft start shown on the right usually work well on smaller tonnage compressors under 2 tons. The two dissimilar metals inside this device cause high resistance when cold, and when heated during the compressor startup, it loses the resistance and allows voltage to flow freely. A true hard start kit is a start capacitor and a start relay that is matched to the compressor's amp draw and winding resistance. If a start kit is added that is recommended by the compressor manufacturer, it is a pretty sure bet that that kit will start the compressor under all conditions. Most start relays have terminals marked 5, 2, and 1 for connections. Between terminals 5 and 2, you have the solenoid coil that opens and closes a set of contacts between terminals 2 and 1. An easy way to remember the correct way to wire a start relay is 5 goes to common, 2 goes to start, and 1 goes to run through the start capacitor. So 5, 2, 1, common, start, run. Here we have a basic wiring diagram for a hard start kit. Terminal 5 is connected to common, terminal 2 is connected to start, and terminal 1 is connected to run through the start cap. The contacts of the start relay are normally closed. At startup, this puts the start capacitor into the starting circuit of the compressor. As the back EMF voltage builds, the start relay is energized, taking the start capacitor out of the circuit. You can check the operation of a start relay to make sure that it's dropping out at the proper time by putting an amp meter between the start relay contacts and the start capacitor itself. An indication of current flow at startup shows the meter to go to 0 after a few seconds, energizing the relay and taking the start capacitor out of the circuit.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.